Hi, my name is Dana Golden. We're going to continue with non-market valuation with a look at revealed preference methods. Revealed preference methods infer the value of non-market goods based on individuals' actual behavior in real-world market transactions. A good example of a revealed preference method is Zillow. I don't know what my house is worth. I actually don't own a house. I live in Chapin. It's a really great way to save on rent, but let's assume I owned a house. I haven't sold it. I'm not participating in the market. It's not in the market. How do I know it's worth? I go to Zillow. I find someone else's house. I'm like, that house looks similar to mine. This other house looks similar to mine. This other house looks similar to mine. I put it together, composite of the three similar houses, and then I look at the most recent sale prices of each of the houses, and I'm like, this is what my house is worth, adjusted for inflation. So key features, it uses observed market choices, directly or indirectly related to the goods of interest. It assumes that individual behavior reflects preferences and total value. There's a problem with this because you don't always observe the total value from the market. Sometimes there are other parts of the value that you can't really take from what is done in the market, and usually relies on actual market data rather than hypothetical survey data. The stated preference method, which we'll talk about in the next video, focuses a lot on survey data. So travel cost method is the first revealed preference method we'll talk about today, and it revealed preference through the economic value of recreational sites by observing how much cost people incur to visit the site. So you're looking at how far are people willing to go to visit Yellowstone, how much are they willing to pay to go to Yellowstone. That tells you a little bit about how valuable Yellowstone is, because this is a proxy for the value individuals place in the site. And it assumes that the less you travel, it assumes that the more trips you take, the less likely you are to take, the more the trip costs, the less likely you are to take the trip. And then estimates the demand curve for recreational visits to derive consumer surplus. So example, visiting a national park, value of a national park. We aim to estimate the recreational value of a national park by analyzing travel costs. Start off by collecting data on expenses, include fuel, lodging, and time. Remember, we have to account for time. We're thinking about the opportunity cost. What else could you have done? Could you have gone to Disneyland? We estimate the number of trips decreases as travel costs increase. We create a demand curve in space where we map quantities onto prices, and we use the demand curve to calculate the economic value visitors derive from the park. We figure out the consumer surplus. And if the consumer surplus is 5%, $5 million, that represents the value to visitors. And next revealed pricing method is, preference method is, the one people most familiar with is the hedonic pricing method, which estimates the value of non-market goods by looking at the characteristics and essentially running a regression to look at how the characteristics affect the price of related goods. So a good example is like, how do housing prices vary with proximity to parks and air quality? It usually requires detailed data on prices and relative characteristics so that you can understand like how there's differentiation in environmental quality that you can use to see the effect of price. It obviously captures use values, not non-use values. There's some intrinsic value that you're never going to get out of the hedonic pricing method. It's kind of in the name hedonic. And it's very useful for looking at how valuable parks and clean air are, because you can say, here's how much a house costs in a polluted place. Here's how much it costs in a non-polluted place. Here's the difference. So a scenario valuing clean air through housing prices. A study examines how air quality affects housing prices in a metropolitan area. Start off by collecting the data. Compile housing prices and attributes, size, location, air quality index. You perform a regression analysis where you estimate how changes in air quality affect housing prices while controlling for other factors. and then you estimate value by deriving an implicit price of clean air from regression coefficients. So if you log model, a 10-point improvement in air quality index increases housing prices by 5%, suggesting that the value on clean air is significant and can be related directly to housing prices. Here's kind of an example of how you can do this equation. You have price on one side, in this case the price of a house, and you have your intercept, beta 0, and then you have beta 1, the size of the house, beta 2, the bedrooms, beta 3, the bathrooms, and then beta 4 is the air quality index. So we're running a hedonic pricing regression. We're using the regression we would use. This is actually a way you would value houses in general. So like often you'd see this even without environmental quality. And then you have this air quality index. And then now this beta 4 is how air quality index affects price. Obviously, you have this error, so you don't have a deterministic regression. You don't have a collapse. So positive beta 4, better air quality increases housing prices. If you have a beta 5, which is in the version of the slides, we had a beta 5, which was distance from park. If that is negative, that means being further away from a park is bad for the house price. So proximity to parks increases house price. So that's how you would do a hedonic regression model, and that is how you should interpret these coefficients. So here's how you can see these coefficients. This is the coefficient. This is what you've estimated in your regression software. Here is the standard error. And so you divide the coefficient by the standard error, and that gives you your t-statistic, and your t-statistic tells you the p-value. In this case, the p-value is 0.051, slightly below significance of the 5% level. And then here are a bunch of significant things. Size obviously very much affects house price, bathrooms to competition price. So you're just trying to create a regression model of housing prices, and then you add back in environmental quality, or the environmental quality measure you're looking at. Another method of revealed preference is alternative pricing methods, which are techniques to value non-market goods and services by leveraging market and behavioral data without directly relying on either stated or revealed preferences. So here you're not working out like what people are willing to pay for the good through the hedonic regression or through travel costs. You're figuring out the value based on the market, but based on transactions that are unrelated to your good, your non-market good. So benefit transfer is kind of a definite version of this, even though it's technically not a revealed pricing method. Replacement cost is another version of this, where you think about how much it would cost to replace the service to the ecosystem with human-made alternatives. Avoided cost, what are you avoiding to the existence or functioning of the environmental resource? This is very useful for, like I said, valuing the Everglades and hurricanes. This is also useful for understanding things that, like clean air, that stop you from getting sick. And then you have the production function approach, which we'll talk about in a moment, which assesses how changes in ecosystem services impact economic productivity. We'll talk about, in a few weeks, or a few videos rather, we'll talk about environmental macroeconomics and how the environment goes into the production function, and this is a way to value non-market goods. Then you have indirect market methods, which estimate the value of non-market goods and services by observing behavior in related markets and activities. You're not looking at someone who's valuing this object directly, but you're looking at similar values. So we are talking about the travel cost method and hedonic pricing method, which are kind of the most important revealed preference methods. We're going to talk about also the damage cost avoided, which values environmental benefits based on the costs avoided. Then you have the trade-off method, which is estimating the value of non-market goods and services by examining how individuals make trade-offs between these goods and other market goods and services. So you're balancing competing preferences, and you're capturing both use and non-use values, which you're not doing through either hedonic pricing or the travel cost method. So it used observed behaviors to identify how individuals are making these trade-offs. Now let's talk about production function method, and then we'll talk about the damage cost method. The production function method estimates the value of environmental goods or services by analyzing its contribution to the economic production process. It links changes in environmental quality to change in productivity of output. It relies on well-defined relationships between inputs and outputs. And it captures the use value derived from ecosystem services. So here's how you would estimate a production function. For those of you who have strong training in econometrics, you'll probably notice that I have not added any log terms here. If you were actually going to estimate a production function in general, you would probably not want it to be linear. You'd probably want some log terms here. But this is environmental. This is not econometrics. So yi is the output of the producer. Alpha is the intercept term. Beta 1, labor I, is the coefficient representing the marginal contribution of labor to productivity. Beta 2, capital. So yeah, like I said, if you're doing this comps Douglas, you would want to log each of these terms, and you'd want to do a little bit more. You want to take the derivative to find the marginal value, but here beta 2 is just the marginal value. So the marginal value of capital is beta 2, and marginal value of labor is beta 1. And then beta 3 is the marginal value of the environmental good, which is some environmental good, like quantity of quality environment, like clean air, pollution services, or pollination services, or forests contributes to the output of productivity. And then epsilon, of course, we have to have an error term. So the coefficient beta 3 reflects on marginal productivity of the environmental good, providing some implicit economic value. This is based on the idea that actually the environmental good is helping us to produce something, and so we need the environmental good in our production function. I want you to keep this in mind until the macro lecture, where we'll talk about this idea pretty explicitly. And then you have, finally, the last of the revealed preference approaches, the damage function approach, which basically is the idea that you can estimate the economic value of an environmental degradation by quantifying its impacts on outcomes such as health, productivity, or infrastructure. How much is dirty air and dirty water making you sick? So it relates environmental changes to measurable damages or losses and captures the cost of adverse effects. It often relies on scientific or economic models to establish causal relationships. So D of I, which is the damage, health costs, and productivity losses for area sector I, is equal to alpha your intercept plus beta 1 times whatever environmental variable you're looking at, plus beta 2 times the population exposed, plus beta 3 times the economic activity. So we're creating a damage function. Last time we talked about, in cost-benefit analysis, we talked about damage function, and here's how you estimate them. So D is damage, A is intercept term, alpha is intercept term. These are the coefficients, and the environmental variable measures the environmental degradation cost on damage. So beta 1 is how much damage is created by a 1 unit increase in the pollutant or the non-abatement of the pollutant. And then the avoided cost method estimates the economic value of environmental goods and services based on the costs are avoided to their existence and functioning. This is very good for evaluating flood control that benefit that's provided by wetlands and estimating the cost of savings from natural water filtration by forests. The idea is that you measure benefits directly by estimating savings from avoided damages. And this is commonly used for ecosystem services to mitigate risks or reduce infrastructure needs. It only captures use values because it only focuses on avoided expenses. So now we've gone through all of the revealed preference methods. Let's talk about some challenges and limitations. First off, they require observable market behaviors. It's difficult to capture non-use values. Fundamentally, when we're thinking about revealed preference, we're assuming there's a market. It's hard to think about non-use values. They're somewhat limited in scope because they ignore broader societal or ecological benefits, and they assume rational behavior by markets, which do not always hold. There may be benefits are not internalized, or maybe people don't know how much things are worth. Maybe they're selling it for too little. It's very difficult to isolate a single environmental factor in market decisions. You saw with the hedonic pricing method, there's a lot of things that go into a housing price. How do you really know what is there? There can be confounding factors that can obscure true relationships. And finally, you have data limitations. Reveal preference methods require high-quality granular data on market transaction attributes. Very good for like stuff like hedonic pricing, where there is a market for housing. It's very available, the market data. Not really good for a lot of environmental goods where it just doesn't show up in the data. Empirical I/O, which is where a lot of this is done as a field, is like traditionally well known for not having the best data and like having troubles getting data. So yeah, that is revealed preference methods. We'll finish this up next time with stated preference methods. I hope you have a great day. Thank you.